Okay, so now we're on the next page. All right, so first thing we're looking at is a tile pattern. Okay, so the first question is asking us to draw figure 0 and draw figure 4. All right, so we kind of got to examine this pattern and figure out what does it look like. Well, as I look at this graph, or these tiles, I'm noticing that there's always a square on the top. There's always this little square, perfect square on the top. So there's a 2 by 2 square there, there's a 3 by square here, and a 4 by square there. So if I'm following that pattern, if this is 2 by 2, 3 by 3, 4 by 4, well the next one must be 5 by 5. And so I'll do my best to make a 5 by 5 square. Remember, nobody's perfect, doesn't have to be great. Okay, now what I'm seeing is that on the bottom it's growing by 1, 2, 3, then 1, 2, 3, 4, 1, 2, 3, 4, 5. So if it's 3, 4, 5, then this one must be 6. 1, 2, 3, 4, 5, plus this little one there, 6. Okay, so now let's go back to the 0. Well, again, this is a 4 by 4, 3 by 3, 2 by 2, so this must be a 1 by 1, just a little one on top. Okay, then I'm looking here, it's just 4, 3, so there must be just 2 there. Okay, so some of you guys might have thought the shape looked like this, but then that wouldn't quite match the pattern that's going on here in the bottom, how we have 3 and then 4 and then 5. Okay, you would have 3 and then 3 again, right? That doesn't follow the pattern. All right, so now the question is, draw a sketch of figure 100 and determine how many tiles are in figure 100. Okay, so, well, I'm sorry, we got to do the table first. So, figure 0 is 3. Then figure 1 has 7. And then figure 2 has, let's see, 13. Then I'm counting this one. This has, let's see, 16 here plus 5, so that's 21. All right, then this has 5 by 5, which is 25, plus the 6 on the bottom, which would be 31. So how do we figure out the rest? Because we don't have any figures to count. Well, we got to figure out the pattern. Now, if I'm going to go from 3 to 7, well, that's plus 4. 7 to 13, that's plus 6. Then from figure 2 to 3, that's plus 8. Then it's plus 10, and you start to see a pattern. How much we're adding by increases, right? So it's plus 4, plus 6, plus 8, plus 10, so the next one must be plus 12, then plus 14, then plus 16, right? Okay, so if we add 12 here, then we get 43. Then we add 14, we get 57. And then the last one, if we add 16, we get 73 tiles. Okay, so that's how we complete the table. Now, but again, the next one asks us to draw a sketch of figure 100. So how do we figure that out? Well, I kind of have to look for a pattern here. So if I'm looking at these tiles on the top, I notice this is a 2, again, 2 by 2, 3 by 3, 4 by 4, 5 by 5 here on top. So we have to, let's start there, okay? So if I'm looking at the figure number, okay, it's 1, and these are 2 and 2. This is 2, 3 and 3. 3, 4 and 4. So the size of the square is one side of the square is 1 bigger than the figure number. So I could say that this is x plus 1. Okay, and that means this is also x plus 1, because the x is the figure number, right? So then here it's 2 plus 1, or x plus 1, which is 3. So x plus 1 here. And then the same thing, it follows the same pattern. 3 plus 1, so x plus 1. Okay, and the same thing here, 4 plus 1, and so x plus 1. Okay, so that helps us figure out what it is here, right? All right, so then for figure 100, I have this huge square here, and it's all, you know, a bunch of squares going this way. I know that for figure 100, that this is going to be 100 plus 1 and 100 plus 1. So that means that it'll be 101 here and 101 here, right? Okay, now we need to look at the bottom here. How does that factor, right? All right, so if I look at the bottom, I notice that this is 3, 1, 2, 3, and then I have figure 1. Okay, so three of them on the bottom. Then I have 4 on the bottom. Then I have 5 on the bottom. Then I have 6 on the bottom here. Okay, so let's look at how that relates to the figure number. Well, these 3, that's 1, that's 2 bigger than the figure number. So the bottom is x plus 2. X plus 2 there, because it's the figure number plus 2, so x plus 2. Figure number plus 2, so 2 plus 2 is 4. Okay, and then figure number 3 plus 2 is 5, so x plus 2 again, x plus 2 again. Okay, so bear with me, okay? So then that means, and remember, you notice there's like 1 hanging off each time, and then we got a bunch of squares down here like this. The length of that, how many tiles there are, you add 2 to the figure number. So if the figure number is 100, it's 100 plus 2, right? So this actually is 102. All right, so now to figure out how many of them. How many did I get? Well, it's 100 by 101. So 101 times 101. And then I have to add the ones on the bottom, so plus 102. So 101 times 101, that's going to be, Mr. Osborne's having trouble with his math here. Let's see, if I do 100 times that, we'll add that, and then we need to add one more 101, so that would be 1,201. So 1,201 plus 102, okay, that's 10,000, sorry, not 1,201, 10,201 plus that would be 303 tiles. Okay, so just hang on. You guys are like, oh, this is crazy. All right, so now if I go to create a function, well, I had to kind of follow this pattern here for the function. To get this total, I had to do this side times this side, 101 times 101. And in our figures, that's x plus 1 times x plus 1. Okay, not squared, sorry. And then we had to add the bottom, 102. So the bottom is represented by x plus 2. So I'm going to add x plus 2. All right? So now I have to simplify this function. And remember, we would start with y equals. So now I have multiplication here, and I have adding here. So what do? Multiplication first. So here, I'm going to use the box and multiply x plus 1 and x plus 1. Okay, so x times x squared, x times 1, 1x, 1 times 1, 1 times x is 1x, 1 times 1 is 1. All right, and then remember, we add up those terms in the middle. So this will be x squared plus 1x plus 1x is 2x, and then plus 1. And I can just take these parentheses down and add x plus 2. And now we're just going to combine all this together. Okay, so I have so I'm going to remember combine the like terms. So now I have x squared by itself there. Let's get a better color right when it's working. So we have x squared there. Then we've got, and that's the only x squared term, then 2x and x, and then the last one would be these constants. Okay, so we're going to add the like terms together. So now y equals x squared, and we have 2x and x, so that's 3x, and then 1 and 2, so 3. And there's our equation. Now, after seeing that, that's a pretty complicated one, right? Now, if you didn't understand that, I have another separate video that's just for tile patterns that I'm going to go over with you, just tile patterns. And we'll look at this example in another one so you can see more about it. If you're ready to move on, just go ahead and keep watching the video. Okay, we're on number 4 on page 2. Now, I know you guys probably can't see the equation very well, so I'm going to write it a little bigger so you guys can all see it. The equation is actually y equals 4 times x minus 1, and actually let me not put it in that spot because there's a glare. So y equals 4 times x minus 1 squared minus 4, okay? So that's the equation I'm going to use. Remember, it's different from what you saw in your paper. So after you watch this, try yours on your own. Okay, so first we're going to write the coordinates of the vertex and put it on our graph. So again, this is vertex form. So remember, we can get the vertex just by looking at the equation. So here, first I look at the number inside the parentheses. Remember, x is a liar. So inside, if it's -1, that means our x coordinate is +1. Okay, the number outside, it's -4. So that means our y coordinate is also -4. Remember, that one does not change. The x will change, but the y will not. Okay? Now it says to find the x-intercepts of the parabola. Okay, this is where we have to solve for, actually you have to solve for the x-intercepts. So I'm going to rewrite this equation down here. But remember, in order to solve, we have to set it equal to 0. Now, the key step here is that when we're solving, we're going to use square root. But before we get there, we have to get rid of this 4 and this 4. So first we start with, this number and then the number in the front. Now, if there is no number here in the front, then you're good. You don't have to do one of these extra steps. You only have to do maybe one step. So just follow along. So first we got to move this over here. First we're going to take our 4 and move it to the other side. Remember, when we move it to the other side of the equal sign, that means it will become positive. So it'll change sign and become positive here in this case. So 4 times x minus 1. Okay, so there's no longer a 4 on this side, it goes to the other side. So now we have 4 here. And remember, we're going to have to square root, but we need to get rid of that number first. If there's no number, then we can square root. So first, to get rid of it, I have to divide the 4. That will cancel it out. But if I divide there, I also have to divide here. Okay? So now I have x minus 1 squared equals 4 divided by 4 is 1. So now you'll notice that I got rid of the 4, I got rid of this -4. So now all I have to do is square root each side. Now, what does the square root actually do? Well, what it's going to do is actually cancel out this square. Because remember, square means I have 2 of something. Square root basically cancels one of them out. So what it's going to do is cancel these parentheses. So now in the next step, so I'll continue up here. Okay, the parentheses cancel out and the square. So now I just have x minus 1 on that side. So now my new equal sign is, or borderline is here. Okay, I emphasize that borderline because some of you guys are kind of switching the equal sign around and putting it in new places. Remember to maintain the equal sign in the same place the whole time. Okay, and then square root of 1 is just 1. Okay, but remember, when you square root a number, don't forget we have both a positive and negative answer or solution, so it's plus and minus 1. Okay, so now to get my x-intercepts, I need to move this number to the other side. So it's going to be now x equals, because remember I removed the 1, so it's gone from here. And that's what I did here with this 4, so it kind of canceled out. All right, so then I move it here, and now that 1 is going to go here, the one I moved. The plus minus 1 is still going to be here on the side. So now I'm going to have 2 different solutions. First, it's going to be x, because of the plus and minus, I'm going to have 1 plus 1. And then my other answer will be 1 minus 1. Okay, so x plus 1 is 2. And then x minus 1 is 0. So there's my two x-intercepts. So let's go ahead and plot them on the graph. 0, 2, right there. And we have our vertex. So I should have plotted that on the graph already. So over 1, down 4. Okay, so we have a graph. Okay, so the next question is find the y-intercept. Now for you guys that are taking my test, you're not going to actually have to find this, but I'm going to go ahead and show it to you. I'm going to leave that on the test, and it'll be like an extra credit question, okay? So what we know about x-intercepts is that the y-coordinate is always 0 for x-intercepts. What we know about y-intercepts is that the x-coordinate is always 0. So to find the y-intercept, I take the equation and since the x is equal to 0 in the y-intercept, then I'm just going to go ahead and plug in for x 0. So then y is equal to 4 times 0 minus 1, because I plugged in 0 for x. Okay. Now, I'm going to go ahead and do PEMDAS, do this in order. So 0 minus 1, that's negative 1. Okay. And then negative 1 squared, we do that first, exponents first. So that's 1. Okay, then 4 times 1 is 4. And then 4 minus 4 is 0. So the y-intercept is 0. It's 0, 0, which is actually that point right there. So I actually didn't even have to do any math, because if you notice, we already have the y-intercept. So now I'm just going to go ahead and make my graph. If you notice, it's really skinny, right? It's really narrow. Why is that? Because we have a 4 in the front. Remember, if it's a bigger number, it's going to get skinnier. Okay? Now, the last part is domain and range. Remember what I told you about domain? It's always the same. It's always negative infinity and positive infinity, parentheses. Okay, range. Does it go down forever? No. It stops right here at negative 4. Does it go up forever? No. It goes, I'm sorry, yes, it does go up forever. And so that's represented by positive infinity. So again, first the negative 4, which we found here, and then comma, negative positive infinity, bracket around our number, parenthesis around our infinity. Now the question is, does this have a maximum or a minimum? Well, it goes up forever, right? So it never has a top, but it does have a bottom. So there's no max, but there is a minimum, and it's negative 4. Remember, it's the y value of the lowest point. Okay?